For the first time, an international team of scientists have found evidence of high-energy neutrino emission from NGC 1068, also known as Messier 77, an active galaxy in the constellation Cetus and one of the most familiar and well-studied galaxies to date. First spotted in 1780, this galaxy, located 47 million light-years away from us, can be observed with large binoculars. The results, to be published tomorrow, November 4, 2022, in Science, were shared today in an online scientific webinar that gathered experts, journalists, and scientists from around the globe. The detection was made at the National Science Foundation-supported IceCube Neutrino Observatory, a massive neutrino telescope encompassing 1 billion ton of instrumented ice at depths of 1.5 to 2.5 kilometers below Antarctica's surface near the South Pole. This unique telescope, which explores the farthest reaches of our universe using neutrinos, reported the first observation of a high-energy astrophysical neutrino source in 2018. The source, TXS 0506+056, is a known blazar located off the left shoulder of the Orion constellation and 4 billion light-years away. One neutrino can single out a source. But only an observation with multiple neutrinos will reveal the obscured core of the most energetic cosmic objects, says Francis Halzon, a professor of physics at the University of Wisconsin-Madison and principal investigator of IceCube. He adds, IceCube has accumulated some 80 neutrinos of tera-electronvolt energy from NGC 1068, which are not yet enough to answer all our questions, but they definitely are the next big step towards the realization of neutrino astronomy. Unlike light, neutrinos can escape in large numbers from exter. Neutrinos could be key to our queries about the workings of the most extreme objects in the cosmos. Answering these far-reaching questions about the universe that we live in is a primary focus of the U.S. National Science Foundation, says Denise Caldwell, director of NSF's Physics Division. As is the case with our home galaxy, the Milky Way, NGC 1068 is a barred spiral galaxy, with loosely wound arms and a relatively small central bulge. However, unlike the Milky Way, NGC 1068 is an active galaxy where most radiation is not produced by stars but due to material falling into a black hole millions of times more massive than our Sun and even more massive than the inactive black hole in the center of our galaxy. Recent models of the black hole environments in these objects suggest that gas, dust, and radiation should block the gamma rays that would otherwise accompany the neutrinos, says Hans Niederhausen, a postdoctoral associate at Michigan State University and one of the main analyzers of the paper. It is already a very well-studied object for astronomers, and neutrinos will allow us to see this galaxy in a totally different way. A new view will certainly bring new insights, says Glauc. These findings represent a significant improvement on a prior study on NGC 1068 published in 2020, according to Ignacio Taboada, a physics professor at the Georgia Institute of Technology and the spokesperson of the IceCube collaboration. Part of this improvement came from enhanced techniques and part from a careful update of the detector calibration, says Taboada. Work by the detector operations and calibrations teams enabled better neutrino directional reconstructions to precisely pinpoint NGC 1068 and enable this observation. Resolving this source was made possible through enhanced techniques and refined calibrations, an outcome of the IceCube collaboration's hard work. The improved analysis points the way toward superior neutrino observatories that are already in the works. It is great news for the future of our field, says Marek Kowalski, an IceCube collaborator and senior scientist at Deutsches Elektron und Synchrotron, in Germany. It means that with a new generation of more sensitive detectors there will be much to discover. Additionally, these results imply that there may be many more similar objects in the universe yet to be identified. The unveiling of the obscured universe has just started, and neutrinos are set to lead a new era of discovery in astronomy, says Elisa Resconi, a professor of physics at TUM and another main analyzer. Several years ago, NSF initiated an ambitious project to expand our understanding of the universe by combining established capabilities in optical and radio astronomy with new abilities to detect and measure phenomena like neutrinos and gravitational waves, says Caldwell. Original written by Elisa King Klemperer. Note: content may be edited for style and length. Journal reference: R. Abbasi, M. Ackerman, J. Adams, J. A. Aguilar, M. Allers, M. Ahrens, J. M. Alamuddin, C. Alisbach, A. Clark, K. Clark, L. Klassen, A. Coleman, G. H. Collin, J. M. Conrad, P. Coppin, P. Correa, D. F. Cowan, R. Cross, C. Dappin, P. Dave, C. de Klerk, J. J. Delany, D. Delgado Lopez, H. Dembinski, K. Diosker, A. Desai, P. Desiati, K. D. de Vries, G. de Wasige, M. de With, T. D. Young, A. Diaz, J. Price, B. Prize, G. T. Shabilsky, C. Robb, J. Rack Helias, A. Racy, M. Ramiz, K. Rollins, I. C. Ray, A. Rahman, P. Reichertzer, R. Ryman, G. Renzi, E. Resconi, S. Reusch, W. Rode, M. Richman, B. Riedel, E. J. Roberts, S. Robertson, G. Rollinghoff, M. Rongen, C. Rott, T. Rue, D. Rickbosch. Evidence for neutrino emission from the nearby active galaxy NGC 1068. Science, 2022. 378, 6619, 538 doi, 10. 1126, Science. ABG 3395. Cite this page. Wisconsin IceCube Particle Astrophysics Center, WIPAC, University of Wisconsin-Madison. Thanks for watching. Please subscribe my channel for more videos.